Hello, everybody. My name is Jose Luciato, and I'm going to be your instructor for the next 14 weeks. We're going to be talking a lot about a lot of web-related technologies, and we're going to learn how to build applications using web technologies, right? And the course is indeed called web development, how to develop applications, but using the web as an infrastructure. Okay? So let's take a look at the material that I've shared with you on Canvas, right? If you go to your Canvas, you should be able to see a lot of resources that I've made available that you should find very useful throughout the semester. Certainly you have the syllabus that we'll see in a minute, but also here you'll find a calendar that basically just lists some important dates that you should be aware of, right? Some holidays, but in particular, right, the last few days, right, when folks are traveling, right, either going either on Thanksgiving or going away and coming back, and and it's a very fast-paced course. So I encourage you to be on top of your calendar, just measuring how much time you have to complete all the work. Right, there's quite a bit of assignments, quizzes, and also a final project, right, that are due to at the end of the semester. The final grades that I need to submit, right, is December 16th, right, at 2 p.m. So that's absolutely the drop dead date by which I need to have everything graded, right? Everybody having resolved any issues. Usually that week before the grades are due, right? That's when we do presentations for our projects, right? That's you'll be meeting with a TA, right, and demonstrating your final project. And that week, it's very busy, right? I'm busy, the TAs are busy, everybody's trying to fit everything. So again, the project is one of the um, uh, types of works that's going to take quite a bit to complete. So I would encourage everybody to get started right away. Um, and um, and what else? So this is an online version of the course, and there's not going to be any difference on whether you take it online or whether you take it in person. We try to be as available as possible. It's a little more challenging since so we're not present, we're not seeing each other physically in the same room. But nevertheless, we have a great TA team that is going to make itself available, and myself. Feel free to reach out specifically on Piazza. So there's a Piazza. We're going to be using Piazza as the major communication tool, right? That you should use to post questions there. It might be that that someone has already posted the same questions before, and you might find that there's already an answer there. So I would start there. But also TAs, there's always somebody, you know, overseeing the Piazza forum, right? So you should be able to get an answer right away. So also, please use Piazza as the main way of getting a hold of me. The TAs are always looking at this. If they would escalate to me if there's any issues. So please start your communication here. Also, when you create a post, you can also choose the individual that you want to send it to. If you send it to instructors, right, all TAs are going to get it. I'm going to get the message. So it could be that you would get an answer much quicker, right? Because there's a team of 10 TAs that are listening for these messages, and everybody's wants to be able to help you out. So that's the best way of getting a hold of us. Just post it to instructors. Right? So if you ever have questions about either some deadline or you're sick or something up that you have to travel, right? Always start off by letting us know. We always want to accommodate, right, some edge cases. Especially if you have a family emergency and things like that. We want to support you as much as possible. So, but again, always start off with letting us know, and we'll try to accommodate you as much as possible. Also, we have office hours. Here's a map. We can see where all TAs are available throughout the week, even on weekends, right? So TAs are available, and there's we're trying to cover as much possible throughout the week, and it's also based on the due dates. We have different sections of the course, and and the due dates are based on whenever we're meeting. So for all the due dates for our assignments, there's going to be the day that we meet, which is on Thursdays, or if we meet on Tuesdays, right? Whatever we meet, that is the due date, for the assignment. We do have 6 assignments. Each assignment is takes about 2 weeks to complete, and so that would take us 12 weeks of the 14 weeks of the full semester, and and so they're due 2 weeks after they're released. So for instance, assignment 1 is going to be released today. We're going to get started together, and so it'll be due in 2 weeks from today, right at midnight. And then you can start working on the second one, right? That will be released in 2 weeks, and then it'll be due 2 weeks later. So the TAs are strategically aligned to be able to be available, right? Especially right before a due date. Also, Piazza hours, right? So TAs are going to be listed here. Who's going to be available at what hour during Piazza. We're trying to, again, we're not done here filling up some holes on who's listening. If no one's there, then I will be listening for questions on Piazza. But again, we want to guarantee a quick turnaround if you're having any questions on Piazza. You can also join this Zoom meeting by clicking this link, and so you should be able to arrive here at this meeting. It looks like it's working. Everybody's joining up. That's great. Thank you. And also I'm sharing here my Git repository. We're going to be doing a lot of coding this semester, right? And it's heavily based on doing a lot of exercises and examples that I call labs, and learning certain skills that you are then expected to use to build an application. Right? We're all going to be building an application throughout the semester. We're actually going to be building Canvas, right? Well, I'm not going to call it Canvas. I'm going to call it Canvas, right? Canvas with a K and with a long B. And so we're going to be building and learning how is it that you would build something like this, and so I will be sharing, right, all the work that we accomplished during class, right? I'm going to be sharing it here at my Git repository. Feel free to reuse any of the source code that I provide in my repository for this section, for this semester. Don't go looking back, right, in previous semesters or anything like that, right? Feel free to reuse any code that I share with you on my Git repository that you can use as a start, right? You can start from there, right, and keep working. We don't know my assignments are fairly long, but I don't expect you to start from scratch, right? You feel free to grab what we worked on together in class, right, and get started from there, right? And presumably you've been paying attention during class, so you know exactly what we worked on together, right? And you can pick up where we left off that lecture. All right, so let's take a look at the syllabus, right, for this semester. So again, the intention of this course is to learn all about web development, right? Meaning we're going to be using several web-related technologies, right, to build applications, right? If you were learning how to use building applications for a phone or a tablet, then we would be using some other infrastructure, right? But you would be building applications, right? But that would run on a phone, right? And then all the technology stack that goes along with that, right? Or if you're building applications for Windows, right, or Mac OS, then it would be that infrastructure, right? And that goes along with learning how to build applications for the desktop. So here we're building applications, but using the web as the infrastructure, right? Which typically follows a specific architecture, right? That we'll see in a minute, that we refer to as a client server, right? That splits up the roles of the application into distinct buckets, right, of responsibilities. Who is responsible for interacting with the user and rendering the user interface, right, and handling events as the user types and drags, right, and clicks on the screen, right, and then who's responsible for converting all that interaction, right, into actionable items, right, that compute something or access data on a file or some network access or stores data in a database, right, and retrieves it, right. But just anything you could build on some infrastructure, you could also build on other infrastructures, with the specific limitations, right, and idiosyncrasies for each one of the various infrastructures, right. And that's what we're going to be learning. What are those limitations? What can you build, right, with web technologies, right, and which we're going to try and point out that you basically build anything, right? Again, with some limitations that we'll point out. Again, assignments, we have 6 assignments. Yes, here's a link for you to join this meeting, right, that we're going to be meeting every Thursday at 7 p.m. Eastern time. And there's a text that I suggest. It's not required, but certainly you can purchase it. But it's suggested. We're going to give you most of the material that you'll need. But it's certainly a great companion, right, that has additional examples, additional material that we don't have time to cover here. A lot of referential content, right, that again, we don't have time to cover here in the lecture, but certainly it's a great companion to the course. So this is the office hours map, right? Each one of the TAs is going to provide a link, right, to their Teams, right, or their Zoom account, right, so they can join them at that particular hour. I'm also going to enable a tool for office hours from the Curry College, right, that you can get in a queue, right, and see who else is already in queue to discuss someone for the office hours, so you don't have to wait. You know how long you would have to wait, right? So you can work on other things and you don't have to stay there. But yeah, the TAs are going to share more on that with you. So here's the agenda for the course, right? So these are broken up into 2-week blocks, right? That the first 2 weeks is going to be dedicated at learning about building the user interface, right, of our web application, right? So we're going to break up the semester into 2 large portions, right? The first half of the semester, which is going to be the first 7 weeks, 8 weeks, is going to be focused mostly on the front end, or how do you create a user interface, right, that is responsible to look pretty, right, and lay out content in all sorts of formats, as lists, as tables, headers, right, scrolling left and right, laying it out horizontally or vertically or in the edges, right, and creating forms for users to fill out, right, and so how do we build that, right? How do we capture the user inputs, right, as a user interacts with the user interface, right? So we'll first start with HTML, right? We'll introduce the basics of the formatting language, right, that allows us to create the structure, right, the raw layout of the application. It's not going to look very pretty, right, but it captures the general layout of the content of the application. It's not interactive, right? It's all static, right? But nevertheless, it's the main language by which we can format the general layout of the application. So we're going to spend a couple of weeks on that. The first assignment is going to go out today, right? It's going to be due on the 19th. Then 2 weeks after that, right, we're going to revisit what we've been building throughout the semester, right? And we're going to start making it look more pretty, right? We're going to introduce cascading style sheets right? It's another language, that is specifically used for formatting the look and feel of the application, right? This is where we can choose different fonts, right? Foreground colors, background colors. We can format things to be left, right, justified, where we can use also responsive design, right? Where the same user interface can be used in many different screen sizes, right? So that anywhere from the really large screen, or right as you resize the browser, right, the content can adapt, right, or can respond, can be responsive to different screen sizes, right, and so it can adapt to a smaller screen, maybe on a laptop, right, or it can then even on a small tablet, right, or even on a phone, right, and it's the same user interface, right, but it's smart enough, right, to reconfigure itself dynamically, right, so that it can be useful, right, in any device. Right? So we're going to spend a couple weeks on learning how to make things look pretty. Then in and assignment 2 is specific on learning about those skills. Right? Then 2 weeks after that, we're going to discuss how to program the user interface. Right? That up to this point, right, for the first couple of weeks, is going to be building things that are static, right, that don't change. Well, other than adapting to the screen size, that's about it, right? Or even hiding or showing content based on the size of the screen, right? Certain times, the screen doesn't fit, certain content doesn't fit, so we might decide to hide or show certain things, right? But other than that, it's going to be static, right, with HTML and CSS. When we get to JavaScript, we're actually going to be able to code, right, and create functions, create scripts, right, create programs, right, that can run on the browser, right, and inside of the browser, we're going to be able to control the user interface, right. We're going to be able to, interact or handle user input, right? So as users click and drag or type something, right, and interact with the user interface, we're going to be able to capture those events, right, and then make changes to different data types, data models that we're going to be using to render user interface, right? So we're going to learn how we can convert data structures, right, either represented as objects, arrays, links, classes and functions, right? And we're going to be able to convert those data structures into an equivalent user interface, right? So instead of this being static text, right, in CSS and HTML, instead, we're going to be able to automate a lot of the this rendering of the user interface. We're going to be able to compute, right, and have the representation of the application as a data structure, and then a function will compute, will convert this data structure into an equivalent user interface, right? That looks a particular way, it's laid out in a particular way, right? And it can handle user events in a particular way, right? Then a couple of weeks after that, we're going to expand on this idea, right? And we're going to learn how we can modify that data structure, right? So that as user interacts with the user interface, right, they're going to be able to create content, delete content, update content, right? Do a lot of CRUD operations, create, read, update, and delete, data, right? And as these data structures change over time, right, as the state of the application changes, right, the user interface needs to react, right, and re-render and display the current state of that application. Right. So that will take us to the end of the first part, right, of our course, right, and so the end of that first half culminates with an exam, right, the first exam, exam 1, which will be in the 8th week. Right now, if this is an in-person class, in the Boston campus or wherever, then the exam would be in person in class, right? So, but if it's an online course, right, the exam usually is available for several days, right? And you can schedule whenever user that you want to take the exam. The same thing for the quizzes, right? There are going to be several quizzes, up to the first exam. So you're going to have a chance to take a look at the types of questions that I have, right? And usually all my questions are somewhat of a puzzle, right? That you have to complete, right? So all my quizzes, all my exams are online on Canvas, and most of them are fill in the blanks, multiple choice, right? And where you have to figure out a puzzle. So I'll give you a puzzle, right? And you have to fill in the blanks, right, to complete the puzzle, right? So that I'll give you some functions, some data structures, right? And I'll tell you how it's supposed to behave, right? And then you'll fill in the blanks so that it behaves and it does what the requirements say, right? So it behaves the way I expect it to behave, right? And so you'll have a chance, 5 quizzes to practice these types of questions, and then the first exam is basically one long quiz, right? I think it's about 100 minutes or so, and there, this will cover the first half of the semester. So everything between the first and third assignment, the content, the topics that we cover from the first to the third assignment, right? It's going to be on that first exam. So anyway, so in the second half of the semester, we're going to focus on the server and database, right, part of the application, right? So basically, web applications are usually broken into 2 parts, right? That we call the client and the server, right? It's an architecture that was, invented, in the 60s, and it's still widely used today. So in the first half of the semester, we're going to focus on the client, on the user interface, right? It's going to be the browser. In the browser, we're going to have code running inside of the browser that implements this client, right? And so that's the first half. And then the second half, right, we're going to focus on the server side, right? And in there, we're going to learn how to build servers, right, using Node.js, and that can listen for incoming requests from clients, right? And then they can run computation on the server, and then fulfill the request that comes from clients, right? And they're going to be able to provide data access, to in-memory data or file systems or databases, right? So we're going to learn how to interact with a Mongo database, right? Is going to be our permanent storage solution, right? That is going to allow us to store things in your data structures, right, for long-term storage. We're also going to be learning how to handle authentication and how is it that folks can log in, right, identify themselves, create accounts, right, and have their own profile, and then how to create relationships between users and objects so that we can keep track of who owns what, right, in a database. Okay. We do have Thanksgiving at the end of November, so obviously we're not meeting that week. And then when we come back after Thanksgiving, it's we only have just another week that we're going to meet right after Thanksgiving, and right after that we have the online project demos, right? So when we come back from Thanksgiving, we're going to learn how to integrate our applications with third-party APIs, right? So we're going to learn, for instance, communicating with, from any number of free data sources out there, right? And I'm going to be playing around with connecting to Napster and ChatGPT. So we'll learn how to use their APIs, right? And then we can integrate the services that they provide, right, as part of our own application. Okay? All this while, you're gonna be working on your project. I would encourage you to start right now, right? At least try to identify a team that you would like to work with, right? So you can have a team of up to 5 team members, right? And as small as 1, right? It is okay for you to work all by yourself. That's totally doable. But yeah, so I would certainly encourage you to to start, finding, who is it that you want to entrust your semester. I would encourage you to keep, small, to keep it small teams. I think a team of 2 or at most 3 is the ideal size of the teams for the project. Bigger sizes makes it much harder to coordinate, and found, my experience has that counterproductive to have large teams, especially if it's someone who you don't know, that you can trust. But if if you guys know each other and you've worked together well in other courses and you can trust each other, then absolutely have up to 5 team members. Let's see, I think there's a question on the chat. Are projects there relative to the group size? No. Jose, I'm having some trouble hearing. Zen, can you hear me? Am I audible?
Yes, but not really clear.
Not clear.
No. But I can understand everything you said. Okay, but it's a little blur.
Is anybody else having problem understanding me? Kat, it's okay. Chris says good.
Okay. It could be my internet problem issue.
Really clear. Yeah, you might want to check on your side. Thank you.
Sure. Thank you, Professor.
Sure, thank you. Jerry says, are project expectations relative to the group size? No. It used to be. I used to do that where I could, throttle the amount of work based on the team size, and I found that it becomes unbelievably hard to grade and be subjective and be objective about the grade. So I don't do that anymore. It's the same size for everyone. Obviously, if you are working alone, on your own, we might be a little more lenient on you, but that's about it, right? If you're working on your own, maybe it will be a little nicer to you. But that's about it. And I think that actually having a larger group, it's actually counterproductive. It makes it even harder. You can tackle less, actually. So making it harder for, well, perhaps it would be a great discouragement, right, for larger groups that make it so hard for like a 5-team group that folks don't want to join in 5-team group. But again, if I would only join a large group if you all know each other, that you can trust that no one's gonna just disappear on you for a couple months. And yeah, so also, if you do find any trouble with other teammates, perhaps not pulling their weight, right, I need to know that as very, very early on, right? Like I can't, this last week or so, or right after Thanksgiving or something, somebody starts complaining about so and so, going AWOL and he's not doing his work, blah blah blah. It's very late in the semester. It's very hard to get into who's really doing what, right? So so that's why I would encourage you to start really early, and make sure that you can trust your teammates. That if you're halfway through the semester, you find some trouble, it's easier for you to maybe switch to another team, perhaps, right? But if you wait to the very last minute, that becomes very contentious, and very hard to determine, right, on who's doing what. There's a question in the chat. Can I group with others in a different section? Yes. But in the same CS 5610, right? In the same course. So there are 3 different sections for CS 5610, and it is okay for folks from different sections to work together. So at the end of the semester, there will be a form, right, that you have to fill out. and in there you'll specify your teammates and also which section you're from, right? And us we're going to have to do all the work of figuring out what grade score goes where in which section. Unfortunately, the real Canvas doesn't have a mechanism for spreading the grades across sections, so we're going to have to do that manually. And we'll have every effort to make sure that we don't screw that up. All right, so that's a week also, that last week that you're doing the demo presentations, right? The TAs are going to share a spreadsheet where you can register for your team demos, right? And basically, we're going to share with you a rubric that it's the same rubric where you list the team members, and that rubric is basically a checklist, and that checklist is basically is taking the requirements of the project, which we'll cover a little later, but formatted as a checklist, right? So even though you won't have that access right away, you can the project requirements are available. We can take a look at it. They're on Canvas, right, as one of the assignments, right? So you already know what you're going to be graded on, and what the TA is going to do is when you meet with them, you're going to demo your project, and they're just going to go through that checklist, right? And they'll say, okay, well, you demonstrate that you can log in, that you can register, that you can create content, you can delete content, you can blah 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 blah, right? And so you'll go through that and give you a final grade. So that week also is the second exam 2, right? And it's not in class. It'll be available for a couple of days, right? If it's an online class, it's going to be available for several days, and you can take it any one of those days. If it's in person in Boston, then yes, it would be at a specific date, right, in a specific time. Okay? And that week, right, again, so going to be a very busy week. I have to have grades by the end of that week and submit it on Monday at the middle of December. Okay, at 2 p.m. Yeah, no, the exam will be typically exams are released at the beginning of the week, right, and they're available for several days. This date is for sections that are in person in Boston. Okay. Any questions? Any other questions so far? Okay. All right, so let's talk about web development and what is web development, some history behind it. Okay. So first of all, we need to know about the infrastructure of the web, right? So it all starts with the internet, right? So the internet is basically a network of networks, right? It's a worldwide network of computers that are connected to each other, right? And they can find each other if they know their IP address or their names of the machine, right? They can establish communication with this wide area network. And so the internet started as a military project, right? That was trying to find out, how to survive World War III, right? and to try and envision what the next war would be. They look back. They look back at World War II and say, well, why did the United States win the World War II? How did we win? And it turned out that the conclusion was that we bombed the heck out of the Nazis, right? And so we made it impossible for them to coordinate, communicate, right, and move troops around. And so we were concerned that that might happen to us, right? And how how could we survive if someone would attack us that way, right? And so there were a lot of concerns on how would we maintain that kind of communication, right? So there was a lot of research, right, that went into building a network that would be able to survive, right, such an onslaught, such an attack. And so the precursor to the internet, right, is the ARPANET, right, that eventually started to be opened up to other institutions other than the military, right, that started bringing in universities here in the United States, laboratories that that academia could participate in this research, right, and then slowly was opened up to academics throughout the world, right, and other institutions with allied institutions, right, that could participate in the creation of this worldwide network, right, and nobody was thinking of creating what the World Wide Web is today, right? But as more folks participated in this initial military endeavor, right? As academics were able to guide a lot of this effort, right? It started to morph into other than something for war, right? But actually a tool of peace, right? So in the in the late 80s, right? An investigator, a researcher, Tim Berners-Lee, working at CERN. He was a physicist. He inadvertently invented the World Wide Web. Right? So by this time, the internet was already fairly mature. Right, the world computers and universities were very well connected amongst each other, but it was a fairly quirky. It was you had to use all sorts of different tools, right, to connect from one computer to the other computer, right, and download files from one computer to this other computer, and then compile somehow the data, maybe some from binary data into something that was viewable, right, and then render it with some other tool. So you had to use like 3-4 different tools, right, to do something that we do today of using just a browser, right? You had to log in and download and then compile and then view. So Tim Berners-Lee was looking for something that was kind of like a single solution, right? That would make it very easy, right? And so his intent was that he wanted to share share his research with his colleagues, right? And he wanted to have a document that would be that you could write it very easily, right? With just plain ASCII, that it could be easily downloaded from a remote machine, right? And that it could be easily rendered on some screen, and that it could have references to other documents, right? Because he was writing research papers, and research papers it's common that research papers reference other research papers, right? And so he had this research idea in mind, right? So he came up with the idea of using an XML like language, right? It was XML was already in vogue, right, as a language for formatting content, right, for creating meta information, and so he used that, right, to create a vocabulary, a different XML vocabulary, which he called HTML, or hypertext markup language, instead of XML, or extensible markup language. So this was a hypertext markup, meaning it was a document that contained content that was active, right? That you could act upon the content, right? In that particular case was that you had hyperlinks, right? That you have words in the text that if you clicked on them, right, they would navigate and go and fetch and download other documents, right? That would be rendered in what he called the browser, right? So he was the first who came up with the idea of a browser, right? That was several tools all built into one, right? It would log in and connect to some remote machine, right? And fetch the content from that remote machine copy it locally onto a local machine, right? And then, parse that content and then render a graphical representation of that, right? Which is basically a browser. He came up with the idea of the URL, right? Of easily being able to, in a single string, right? Indicate the remote machine, right? Or the IP address, right? Maybe the user name of who's communicating, right? And then a path that allowed you to reference a specific document in that remote server, right? And then you could easily embed in your HTML document so that you can link to different documents spread out over the internet, right? So inadvertently he invented the World Wide Web, right? And in the late 80s, right? And this obviously sparked an entire revolution, right? Which is still ongoing. So just a few milestones of historical importance, right? Certainly in the 60s, there was a lot of effort to come up with the infrastructure, right, of the internet, and there was a lot of competing architectures, right, of hardware, of protocols, right, and of how is the communication going to happen, between all these different machines. That you could be able to send a message from one machine to another machine anywhere in the network, right? And it had to traverse, right, from your machine, hopping across multiple machines all the way down to the destination, right? And that it should be able to reroute itself, right, automatically if certain machines were down because they had been bombed, right? They were taken out. So it would have to find an alternative mechanism of reaching that destination. So all that research went into building the infrastructure of the internet and the protocols and whatnot, right? Then in the 70s, out of all these alternative of how to build this architecture, one particular architecture became very prominent, with that we refer to it today as the client server architecture. And this is basically specific roles that different computers take upon, right? Where one of the computers is referred to as the server computer, and the other one is a client computer, right? They're both computers, right? But one of them might be a little more powerful than the other, right? And one of them, and they're both running software, and in the server computer, you'll be running the server software, right? And on the client computer, you'll be running a client software, right? And the different roles, right? They have specific roles or responsibilities. The server having the responsibility of being able to handle multiple clients, right? So multiple clients can connect to this one server, right? And the server being able to maybe queue them up, right, and handle them in a particular order, right? Being able to give them access to resources that would be too expensive to replicate in every single client, right? So, for instance, if you have a printer, right, it used to be so expensive, right, that there was one printer, right, and all sorts of clients. Instead of everyone having their own specific printer, usually you have just a dedicated server that would handle requests to print something, right? And well, you still today is very common that we have this architecture, right? We send out some requests to a printer server, right, that queues up all of these requests, right, and then prints something. Back then, also, it was the case that you have a file server, right? Again, it used to be that memory wasn't as cheap as today, right? So instead of everybody having, memory in their own local client machine, it would be that it was shared amongst multiple clients, and you have one single server with a big, file server, right, that was shared amongst multiple clients, right? So you'd be able to go fetch these files from one central place. And so this architecture, right, is still around today. It's very common that we still use this kind of architecture today, right? Your browser is your client, right? And if you go to Amazon.com or CNN.com, wherever you're going, right, Wikipedia.org, right, all those are server machines, right, that are running server software, receiving the requests from millions of clients, right, that are bombarding these servers, simultaneously, and those servers are pretty beefed up, right, and they have to be able to, receive all these requests from millions of client browsers, right, and they have to be able to serve up different documents, to the different browsers. Yes, so yeah, so absolutely, this is an architecture that is still relevant today. Another important milestone was, in the 80s, we start to see the personal computers, where instead of having these dumb terminals, right, that relied entirely, mostly on the server, on the remote server. These dumb clients were very slow, very clunky. They're couldn't do much on their own, right? They relied on sending the request to a server, do the computation on the remote server, right? Now in personal computers, the memory becomes cheap, CPUs become cheap enough, right? The hardware becomes cheap enough that folks can actually purchase one of these computers and take it home, right, and put it on their desktops, right? You start seeing the Macintosh, right? Microsoft also, with its own OS, MS-DOS operating systems, right? And then there's an explosion of everybody owning their own personal computer. And so the client server architecture was not as relevant, right? In the when personal computers start to come out, right? People would run their software locally on their machine, right? They would not rely as much on a remote server. Not until the World Wide Web came out, right, in the 90s, where now the universities, right, are and the students in the universities and the faculty start using the World Wide Web invented by Tim Berners-Lee, right, to publish their research papers and for homework, providing syllabus and all sorts of content for their students, right? And students themselves start to create their own content, and then just the content starts growing exponentially, right? It becomes a sensation, right? A worldwide sensation. And so now these personal computers, start to consider, also connecting to this World Wide Web, right? And so instead of, you start seeing a lot of the applications that folks were running locally on their local machine, start to kind of like navigate or migrate to be implemented as server applications. Right? So we're kind of going back to the client server architecture that we had kind of went throughout the 70s. Now we're going back to that, where applications are no longer necessarily just running locally on your machine, right? But now there are applications that are running on a remote machine, right? And then you just have a browser, right, to be able to access those applications and render the user interface, right? For instance, this is Google Slides, right? This is Google Slides. This application is it's PowerPoint, yes, but it used to be PowerPoint. It would run locally on your machine, right? And you would distribute it as a CD. I don't know if you remember what a CD is. And you would install it on your local machine and it would run on your machine. Now, right, Google Slides replicates the same functionality as PowerPoint, but it's running entirely on server, right? And the server is maintaining a local database for us, right, for our own login, for our own identity, right? And then this browser is a client application, right? It's a JavaScript application that is running on the browser that is fetching data from a server, right? Retrieves all that data from the server and then renders these slides for us, right? Again, and this is what we're going to be learning, right, in this semester. How is it that we can create these applications that used to be that you would run them entirely on a local machine, but now you can recreate the same application, but on the web, right? Something that was exclusively running on the desktop can now also be implemented as a web application, right? So this is one of the examples of something that used to be a desktop application is now a web application. Okay. Oops. Uh-oh. Sorry. So we see in the 2000s, we see that a lot of applications that used to be desktop applications, become now web applications, right? And accept the World Wide Web as an infrastructure, right? That can host and run these applications, giving you all the necessary tools for building entire applications. And also in the 2010s, we see the rise of mobile computing, right? All these, so the same thing that happened for the desktop applications, creating these personal computers that, they were small enough and cheap enough that you can buy and take home. Now they're small enough, right, and cheap enough that you can put them in your pocket, right, and take them with you. And the amount of traffic and use consumption of content, just grows even faster, even more exponential, where we're collecting huge amounts of data, about each user, right? And we're creating far more data that we can possibly consume or make sense out of, right? So who knows what's next, right? In the 2020s, 2030s, Neuralink, plug in your phone on in your head, connected to a satellite or whatever. I don't know. Um, so that's a general set of milestones that were happening in on the internet now. Also, following this architecture of client server, right? There was also happening things specifically on the client side and specifically on the server side, right? So let's look at the server. What was happening on the server side? So right after the this World Wide Web started to come out, in the late 80s, early 90s, again, there was a huge explosion of folks, creating all sorts of things, right? What can I do with this HTML stuff, right? And this browser thing and this server thing, and they quickly ran into a limitation, right? That HTML is static, right? It's content that, I mean, you make it look pretty and whatnot, but it's static. It doesn't. If you write an HTML document, that's all it is, right? It doesn't change over time, right? So what happens if things do change? You would have to manually go in and change the HTML yourself. So that would not do, right? That was quirky. So what if I wanted to write a weather application, right? That gave you the weather as it changed, over time, right? Maybe hour to hour or day to day, right? I want to be able to have an HTML that actually would be dynamic. It would change over time, based on the data as we received it. So we needed to create a mechanism for computing this HTML instead of being static. So we needed a function. We needed to call a function, and this function would execute in the remote server. The remote server would create the HTML on the fly, right? And sometimes it would create that it was sunny, sometimes it was rainy, sometimes it was cloudy, right? And it would use the correct images, right? The correct links, the correct text, and we'd be able to build this HTML dynamically, and come back to the browser for rendering. And so that was the core technology for that, where it was implemented in the early 90s, and this idea just took off. It says, oh, this is great. I want to be able to dynamically create content on the server. PHP was one of the more successful implementations of this idea. There were many competing technologies that were doing the same thing, but PHP certainly, just took off like crazy, right? Another competing technology that was also doing the same idea of generating content on the server, creating HTML on the server, was Java. Java, in particular, the Java 2 Enterprise Edition, was very, very successful at creating a framework for building these types of applications, right? That you wanted to compute content on the server, right? HTML on the fly. And so they came up with a very robust architecture of how to build these applications. Right? They came up with all sorts of best practices, design patterns, right? That's where the model view controller became very, very popular, right? Of how to break up large applications into constituent pieces of the model, the view, and the control, right? Soon after, .NET also took a lot of these ideas from the Java 2 Enterprise Edition and improved on it, right? Made it even better and expanded the language, right? Just from Java, now you would have also Visual Basic, C#, right? Other technologies that took on this same strategy was to Ruby on Rails, Django, Flask, again using different languages, Python. So today, we're in the late 2000s, Node.js comes out, right, which was a JavaScript runtime, right, that allowed us to run applications using JavaScript. We'll see how that is relevant in a bit. Now, okay, so this is happening on the server, and the idea was to create content on the server and have a graph here that might be very useful. Here, put it here. So using these technologies of rendering content on the server, right? This is the architecture of this type of application. You have Alice here going out to a browser and asking for a dynamic content or a page that is not static. So she's not asking for HTML. She's asking for something that is dynamic, that will render on the server. So the server, this would be either ASP or JSP, PHP, Python. There's many different iterations of this idea. And then on the server, this code would execute on the server. It would compute the HTML dynamically, right? And then it would stream it to the browser, back to the browser. Now the browser, as far as the browser is concerned, the browser can't distinguish on whether this HTML is static HTML or if this is HTML that was dynamically generated, right, on the server. It was computed by some function, right, on the server. It just sees, static ASCII, right, from the browser's point of view. From the server's point of view, the content is indeed dynamic, right? It would maybe did some network connections, it accessed the database, right, or did some computation, right, and it computes this HTML that goes out to the server, and then Alice sees this content, right? Now, in parallel to the server, there was a lot of effort on the browser side, right, on the browser side, and of being able to run code, run programs, executables, but on the browser side, on the client. So we're talking about code that could run on the server and code that could run on the browser, right? On the server, that's Python, Java, C#, right, Django, all these, right? But now on the client, also there were a lot of efforts to say, well, what can we do on the browser? What can we run on the browser itself? And that began with, in the mid 90s with JavaScript, right? Netscape, came up with using this Java-like language that could execute inside of the browser. Now they had a lot of pushback on this idea because this, folks were saying, wait a minute, I have my browser, I'm downloading code from some server that maybe I don't trust, and that's going to download on my browser, it's going to execute on my local computer. People started balking at that and saying, no, I don't trust that. And what is this JavaScript doing on my browser? So folks kind of pushed back on this. Now this gave opened up a little bit the opportunity for competing technologies such as Adobe Flash. These were binaries, right? That had already been compiled on a server that were downloaded, but they were executed inside of a plugin, right? It was a plugin that Adobe was able to market as safe, right? That any executable that was running inside of the plugin, wasn't accessing your file system, it wasn't tracking your keyboard, right, and things like that. And this was very, very successful. A lot of content came out for Adobe Flash, lots of games and brochures and a lot of really good content. But nevertheless, JavaScript kept kind of like chugging along, right? And so in 2005, almost 10 years later, right, JavaScript had started to become mature enough, right, that it was again be able to be considered for building applications that run on the browser, right? And Dojo was one of the first libraries, JavaScript libraries that was fairly successful. All this time, in the early 2000s, there was a lot of money, a lot of investments that went into building applications on the web, right? So a lot of big players started to compete here. The Microsoft, Oracle, right, start to compete in this space, and each one is kind of like competing for the supremacy of the browser. The browser now becomes kind of like the window to the world, right? Whoever controls the browser, right, control the world. So some of that effort caused fragmentation in the JavaScript language, right? Each browser was kind of, because the code was being run on the browser, each browser was kind of free to interpret the JavaScript source code different ways, right? And so each one of these vendors was trying to differentiate from each other, and maybe providing certain features of their JavaScript that was slightly different, right? And try to entice developers away from their competition and say, hey, check out my JavaScript. You could do this on my JavaScript, but you can't do that on their browser. So come over to my browser. Right, one of the worst offenders on this was Microsoft, right? Where they had their own JavaScript version and whatnot, and it was very incompatible with other versions of JavaScript. So there was a lot of fragmentation of the JavaScript language. So jQuery came along and tried to solve this issue of the fragmentation of the JavaScript language, and it tried to do what Java did for the desktop, right? So remember, Java, what they try to do is says, well, if you program in this language, you won't have to care which operating system, right? You can just code in this one language, and then the compiler will compile it and interpret for different operating systems. Yes, and it didn't turn out very exactly the way they wanted, but jQuery was trying to do the same thing, right? It says, well, if you use not this version of JavaScript, but if you use this library, instead of using native JavaScript, if you use my library, then you won't have to care which browser it's running on, right? It'll create a veneer abstraction on top of the browsers so that you can code to the jQuery specification, and then it'll do the correct conversion to whatever browser was underneath, right? So that instead of coding for Safari or coding for Netscape or for Firefox, right, and all of these, jQuery did that for you. And so this was the beginning of creating layers of abstraction, right? That you didn't have to explicitly, code to a specific browser, right? The idea came out and says, wait a minute, I could have a layer of abstraction and kind of forget the fact that I am running on one browser versus another, right? And so this idea took off, right? This veneer, this abstraction layer. And one of the first very successful applications of this idea of creating an abstraction layer was Angular by Google. Google came up with the idea of saying, hey, we could create this nice thick layer of abstraction, maybe do a lot of the great things that Java and .NET, invented a decade earlier, right? All these design patterns that they came up with, the singleton pattern, the control pattern, model view controller, right? All the design patterns worked very well on server-side applications. Maybe we can learn from that and bring over to the client side, right? And yeah, so Angular is a very powerful, very thick layer of abstraction on top of the browser that allows you to implement all these really cool design patterns. In between, there were quite a few other competing technologies with different level of success. But in mid 2000s, early 2010s, Angular in its second iteration, Angular 2, I think they made a strategic mistake, and so their next version of Angular was so radically different from the first one, much better, absolutely much better. But there was all the investment of companies that had invested in Angular 1, all the code that they had written didn't have an easy path forward, right, to migrate to the new version of Angular. And folks said, some of the companies said, I'm going to have to rebuild all this. Everything that I wrote prior, I'm going to have to rewrite it for version 2. No way. So people started to investigate what new was there, what other technologies were there, and there was React.js ready to, with open arms, saying, hey, check me out, right? And React.js, here is where it took off, as a very simple idea. Says, I'm not as powerful as Angular. I'm no way as hard to learn as Angular. I just render the user interface. I don't do any fancy design patterns, right? I don't have any opinions on how you talk to the server, and the state management, any of that, right? I don't have any of those fancy things. I just render stuff on the browser. That's all I do. And folks like that, that simplicity, and be able to use maybe other libraries for other purposes, right? Like connecting to the server, databases, and things like that. As opposed to having one single monolith, library or infrastructure, right? So React.js is basically just a library, right? Much thinner, much easier, whereas Angular is an entire infrastructure, right? That is, it definitely has a much higher level of learning. Okay, but yeah, so we're going to be using React.js in this semester for building the user interface. Okay, and that's what's going to be the focus of the first half of this semester, right? Now, using these technologies, the client server technologies for rendering the content dynamically, right, has a different implementation as using server. So this is the server. Here's how server applications render. They compute the content on the server, right, and then they stream it to the browser for rendering. Now, when you use React.js, it's slightly different. Wait a minute. It works this way. Right? Let me show it right here. So now this is what our applications are going to look like, right? You still have your client and your server, your browser and your server, but the rendering, right, the dynamic HTML is created on the browser side, not on the server side. Right? The server provides some template, right? Some HTML templates, some JavaScript code, right? That is downloaded, right? It's downloaded on the browser, and in the browser we execute this JavaScript, and the JavaScript will render the dynamic HTML, right? It will manipulate a data structure in the browser, right? Which will be converted into a graphical representation of that data structure, right? And it will render the screen. So the server is not generating the content, the browser is generating the content. Now, obviously, there's some limitations to this strategy because oftentimes you need data. Right? You need data that typically is stored in some remote database, and in a browser, I don't have that. Right? The browser doesn't have access to the database. Right? Whereas the server does. The server does have access to a database, to the network, whatnot. So it often is the case that the browser needs to go back to the server for data. Right? Does a request for a server says, "Hey, give me some data." The server might go out to a database, right, to a network, right, and then come back with data, and then the browser will run the JavaScript in the browser, right, and then you manipulate the data structure and re-render the screen accordingly. Okay. Now, this is the modern way that applications are built today, web applications. Google Slides is built like this, right? Google Maps, all the Google applications are built using this strategy, right? Now, commercial applications, like if you go to Amazon or things like that, those applications are typically built in a combination of the two. They'll use this technology, right, for things that need, heavy computation, that you need a lot of server-side resources, and that you need to run a very complex algorithm on the server. Right? So that's better to, have the server, because these are supercomputers, right? They're very expensive and they can do computations like nothing, right? Oftentimes they maintain, large amounts of cache of things that have already been computed, have already been calculated, right? That you don't need to recalculate, right? And you can go to the server for this content, like landing page. Whenever you come to a landing page to a one of these websites, you want to minimize the amount of time, right? That between a user coming to a website, to a landing page, you want to pump as much content to the user as fast as possible. Okay, and so usually for that application, you would use this technique, right, where you do the computation on the server, or even have a lot of cache or pre-calculated, pre-generated content that you can pump out to the user as fast as possible, right, within 50 milliseconds. Right, you want to be able to catch the user's attention, and then with as the user starts to navigate and click and drag and go from different places, and view products or reviews or things like that, then they'll use this other technique, right, where they'll go fetch for data from the server, right, and then dynamically render it on the client. Okay, but we're going to be focusing on this part, right, because this is what most of the applications today are built out of, right, and this is more for high performance particular applications, right, or particular web pages that need to be very performant. That we're not looking for that, right? We want to know how is it that we render in content applications. Okay, but yeah, so the architecture that we're going to be discussing is all these networks, all these servers, these clients, right? But we want to focus on one of these, right? One of these boxes here of one client and one server, right? We're going to first focus on just one client, one server, and then in the second half of the semester, we'll talk about, when we talk about the server, we'll talk about how would you handle multiple clients, right, connected to a server, right? And maybe that server going out to some other server to fetch data, right, and retrieve it and then make it available to the client. Right? So we'll expand on that in the second half of the semester. So the first half, focuses on this client over here, right, of browsers rendering content, fetching some HTML, some JavaScript, right, from the server, right, and then rendering the content on the client, right? That's the focus of the first half of the semester. Okay. Any questions on that? All right, so let's talk about Node.js. Right. So Node.js is a JavaScript runtime, right, that allows us to execute JavaScript on the desktop. Right. Typically, when we think of JavaScript, right, we think about, right, code that is executing inside of a client or browser, right? And that's true. That's where JavaScript became popular, became famous. Right? That's where most of its life has been, right, on the browser, on the client side. But since then, right, in the late 2000s, right, Node.js, they took the engine, the interpreter that was being used on the browser, and they created a version of it that could execute on a desktop, right? That you could execute now code, JavaScript code on the desktop. Obviously, you have limitations, right? Because JavaScript running on a browser, you have a canvas, you can draw on the canvas. On a browser, you have a window, you can interact with the mouse, with the keyboard, right? But running on a browser, you have limitations of who can you connect in the network. You don't have access to the file system, right? You don't have access to a database, right? Now, JavaScript running outside of a browser, right, on a desktop, doesn't have those limitations, right? It can access the local file system, it can do network communication, it can talk to a database, right? So it can do all the things that the JavaScript running in a browser can't do, but it can't do the things that JavaScript running in a browser can do, right? You don't have the user interface, you don't have a canvas, you can't draw on a screen. There is no screen, right? So code that runs on a browser and JavaScript that runs on a browser and JavaScript that runs on a desktop can actually complement each other, right? If they could communicate with one another, right? And that's exactly what we're going to do, right? We're going to have JavaScript running on a browser, right? That's going to be our React.js, right? That is going to be rendering the user interface and interacting with the user as they click and drag and whatnot, right? But it's limited, right? It doesn't have access to the file system, doesn't have access to the not unfettered access to the network, right, or database, right? But we're going to complement that, right, with JavaScript running on a desktop, okay, which is not going to have any of those limitations. Right? It's going to be able to access the database, access the file system, the networks, right? It's going to be able to do all the things that JavaScript can't do in a browser. And they're going to complement each other, right? And they're going to talk to one another through HTTP, right? They're going to exchange, ASCII back and forth, right? Formatted in a specific format, right? Either JSON, JavaScript object notation if it's data, right? Right, or HTTP sending requests over HTTP, sending get, post, put, deletes, right? In data and encoded in the body, and so using this HTTP communication back and forth, basically our JavaScript running outside of the browser is going to play the role of the server, right? In a client server architecture. Okay. Now we're going to focus our the first part of the semester, right, of doing React.js, right, running on a client on a browser, and the second half we're going to focus on Express, JavaScript running on a desktop to implement a server. Okay, and so first we're going to focus on this. Now, this React.js, right, is going to be JavaScript running in a browser. Now, this JavaScript needs to be downloaded from somewhere, right, from a server. So for that, there's going to be a little server here, right, that is going to be running locally in our machine. And that is going to host our JavaScript that's running on a browser. Right? So it's a little server, right, that allows us to develop the user interface, right? But it's not going to be this server over here, right? It's just going to be a small little server, right, for development purposes, right, that is going to allow us to implement the user interface, built on React.js, right? And it's going to render the content using technologies such as HTML and CSS, right? Plus JavaScript for dynamically computing what the user, what the content is displayed for the user. Okay, right. So the different technologies that we're going to be focusing in the first half of the semester is HTML, right, which stands for Hypertext Markup Language. Right? That I'm big on acronyms. Right? So on all my quizzes, you'll find a question about an acronym. What does HTML stand for? Right? And you'll have to tell me hypertext markup language. Right? What does CSS stand for? Cascading style sheets. Right? And so these are technologies that allow you to lay out the content of the main content, where we're using tables, lists, headers, paragraphs, right? And the logical structural content. And then CSS, right, is a technology that allows you to paint, right, or use different colors and fonts and whatnot, right? And then JavaScript is be able to compute this dynamically, right? And so So JavaScript, right, is a language that typically runs in the browser. Now we're going to be able to run it outside of the browser. And in particular, we're interested in running it on the desktop so we can create servers, right? And that's what we're going to learn how to do today, right? So first of all, you'll need to download Node.js. You can go to nodejs.org, right? And you can download the latest version of Node.js. Just download the installer, run it, go through the different prompts, right? Just accept all the default settings, right? And make sure that it's installed on your local machine. Once it's running, you can try it out, see if it's installed correctly. You can sort of node -- version, right? And it'll print out the current version. I think it's like 24, 25 or something. And then we'll be ready to get started and create our projects, right? So please, in your local file system, create a directory that anywhere you want, as long as you remember where you put it, right? But I would suggest that you create a folder for this year, right? Then in there for your particular semester, if it's winter, fall, spring, whatever, right? In there, create a directory called web dev. And then in web dev, right, that's where we're going to be doing all our work, throughout the semester. Okay. So let me demo that. I believe I might have already done that. Right. So yeah, I have users, Janinzi, blah, 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 2024 fall. That's where we are. So I'm going to create instead of web dev, I'm going to create a folder, right, for this course, this section, right? So I'm going to make for CS 5610, right? And in there, right, it's empty. And so here, this is my equivalent of your web dev directory. In here, we're going to create a couple applications. In particular, we're going to create two applications. One in the first half of the semester and the other one in the second half of the semester. The first one is going to be a React web application. And the second one, the second semester, is going to be a Node.js server application, right? So we're going to focus first on the React web application, okay? All right. All right, so let's first create learn how to create a React web application, right? So it'll be the simplest of React web applications, right? Just to get you going. So what React is a library that is put out by Facebook, right, that allows you to very easily render content on a browser programmatically, right? That you can create functions, right, that can compute what the user interface is going to look like, right? It allows you to combine HTML, these pointy brackets, right, and this XML-like language, right, and dynamically generate this XML-like language, right, to render something on the screen. Right? It's basically a function, right? It's a function that its output is a user interface, right, made up of a whole bunch of HTML nodes. Right? And so your function is you have to write an algorithm that computes what the HTML is going to be pumped out to the user interface. Right? So let's create our first React application. Right? Let's create it. I'm just going to copy this here. And I'm going to paste it. All right. I'm going to change the name. And this will be Canvas React Web App. So this command is npx. Right? Npx is an executable that comes with your Node.js runtime. Right? So once you install Node.js, you get this executable. Right? And what it does is that it's a node package executable. Right? It can execute node packages. Right? And in this case, it's executing a popular node package called create React app. Right? And so this is a package that is put out by Facebook. right, that can create a minimal React.js application that is already configured, right, to to run as is. It already implements all sorts of great design patterns. Already creates gives you a whole bunch of tools for compiling and running and serving up your React application locally in your machine. Then this is the name of the machine, Canvas React Web App. Okay, but I'm going to change it a little bit so that I can tell which version it is. So this is CS5610, right? And this is fall 24. Then there's templates, TypeScript. That means that we're not going to be using plain old JavaScript. I mean, the language JavaScript has taking a lot of slack, right, for not implementing certain features that are very common and they are expected in modern languages, right? And one of those features is that it's not typed. Right? JavaScript, it doesn't. I mean, it has types, right? But it doesn't enforce them. It doesn't validate them, right? And so there's a better version of JavaScript called TypeScript, like the name suggests, right? It's JavaScript plus types, right? It's somewhat what C++ did for C, right? And C was not an object-oriented language, and what C++ did is says, okay, well, I'm going to take C, right, but I'm going to add a whole bunch of other syntax, right, that allows you to work with classes, right, and inheritance and all these things. So TypeScript is kind of does that with JavaScript. It says, you're missing all these other modern features, right? Well, I'm going to add them to you, right, so that you're now going to have types, right? So let's do that. So it's going to create a folder for us called Canvas React Web App, CS5610 Fall 2024. Right? And now this is going out to a repository, NPM. NPM is a repository for Node packages and Node modules, right? That where you can host all sorts of open source applications and tools and packages, right? That you can download, and that's where we're executing this from. Right? All right, so let's see. So I created this folder. We can go in there, right? And we have the content here. You can see that there's a file here called package.json. See that? So that file, this tells you immediately that this is a Node project, right? This JSON file. JSON stands for JavaScript Object Notation. So it's a file that contains JSON, right? It's an object. We can look at the content. JSON. So it's a JSON. It's an object with a name, value pairs, properties, and whatnot. And one of the important things is that it has this content here. Right? It says dependencies, saying that this particular project depends on these other projects, right? These other libraries that need to be installed locally so for this to work, right? In particular, notice that it has all the React libraries, right? That put out by Facebook, right? That was going to allow us to manipulate the browser. That DOM there, React DOM, is going to allow us to draw content to the browser, right? Plus, it's downloading all sorts of TypeScript support, right? So that it's enhancing the JavaScript to be a more modern JavaScript, right? Plus all the glue that allows JavaScript, right, to be understood as a TypeScript version. Okay. Plus, you see here some scripts down here that allow you to start this project, right? So we're going to now run that script. That's start, and it's going to start up a little server that is going to host our React application. Plus, you have here build that converts this this high-level component-like application into something that can be deployed on a browser, on a server, remote server. Okay. All right, so let's run it. So we can say npm start. So this is going to start a little server, a Node.js server, and it's going to host a little application here, right? And there it is. So this is the boilerplate, standalone, simplest hello world application, React.js application, right? And so our work for the next 7 weeks, right, is that we're going to replace this boilerplate function, right, that now, computing this content. We're going to replace it with our own implementation, right, with labs and exercises, and we're going to be building Canvas. Canvas. We're going to be building Canvas, right? So we'll replace this throughout the next several weeks. Okay. Okay. Yeah. So, and notice that it's running. It's listening for incoming requests as I click and whatnot. Now to stop it, I can say Control C and it stops it. It stops the server. All right. Okay, so we have our application there, our simple application. Oops. It's running. There it is, npm start. It runs. And now let's open it up with our favorite IDE so that we can explore what's in it. Right? And in there, we'll find several folders in there, node modules, the package JSON that we just saw, right? So let me open it up with my favorite IDE. So I'm going to be using Code to do all my work. I highly suggest that you use Code as well. So let's open it up. Let's say File, Open Folder. So I'm going to navigate to where I install that. Things in U. It's this one. Let's say Open. Okay, there it is. And so yeah, so there's the package JSON I was showing you just a minute ago. Notice that this is already a Git repository, right? So it's keeping track of any changes, files, and whatnot. And that's great. That's going to allow us to deploy it easily to a remote server. Node modules is all these dependencies. These are all the libraries that our project depends on. These are all downloaded, compiled, and installed under node_modules. Right? This is this directory contains all the binaries, right, and executables, right, that are the dependencies of our project. Now, this node_modules should not go ever into your Git repository. If you look at your Git repository, notice that it has a git ignore, right, and it says that that directory should be ignored. Right? So this is boilerplate. The project is nicely configured to ignore certain things in the repository, your env files. That's great. Your node_modules should never go in your Git repository. Perfect. Right? Then you have public and source. Right? And in public, you have this is what our little Node.js server that is running right now. It's hosting the content in the public directory. Right? And in there, you have a very specific file, which is the entry point of the user interface of what you see on screen, right? Actually, I think I stopped the server. Let me run it again. Okay. And so what you see here on the screen, this localhost 3000 is actually, this is the URL that is going out to my local machine, my local host, that is hosted at 127.0.0.1, right? So that's my local machine. Right, so that's the IP address of my local machine, and that's the port where the server is by default running and listening for incoming requests. Right, and so the server is my browser is generating this request out to the server. It's downloading a particular piece of content. What is downloading? Well, it's downloading this one file, index.html. What's in here? It's just HTML, right? You have here, very common content of HTML, right? You have the opening tag that contains two elements, the head element and the body element, right? We'll go on that in a second. And then in the body, you have the actual content that is being rendered. And what is being rendered? Just that, right? Which is weird, right? Because when you see this, it looks more than just that, right? And actually what's happening, right, is that what is being done here is that JavaScript is executing magically, right? And it's automatically injecting content into the element in there, into that div with the ID root, right? So how is it doing that? Well, under source, there's an index.html as the entry point here for the public directory. Here, the entry point under source is index.tsx, right? And what is that? Ooh, it's something that looks very much like Java. It's JavaScript, which is not JavaScript. It's TypeScript. TypeScript is a much more modern version of JavaScript, right? And what is it doing? Well, it looks like it's importing a whole bunch of other code, which we're not getting into in a minute, right? But we see here the root that we just saw earlier, right? We saw that root here in the index.html. So somehow this ID root, right, is being referenced from this index. So it's grabbing that root as a reference. And once I have a reference to it, I am rendering the following content in there. Right? I am injecting that content into that root. Okay. And what am I injecting? Some weird looking, pointy bracket stuff in there. In particular, I'm injecting this one app over here, right? What is that? Oh, it's something that's being imported, right? That is right here. This app is actually over here, this app.tsx. See that? And what app.tsx is that it's a function that is calculating, it's returning some static content that happens to be an image, a paragraph, this paragraph, see that? Look at that. And a hyperlink, learn React. There it is. This is the content that we're seeing there. See that? This content is the result of this computation. So this function returns this HTML content, and we'll come back to this in a minute, right? What this div and header and a and paragraph. We'll come back to that in a minute. I just want you to, very, very high level, what's happening here, right? This function is computing the display, the user interface. What you see on the screen is being computed here. This is what's being computed. This is what you see on the screen. Okay, so it's the result of this return. This app is taking that input and it's rendering it in the root. And the root, what? It's that index here. This index declares that root, so it's injected in there. See that? So that's what's happening. Here this is rendering what? It's rendering what's in the app.tsx. Everybody good? Okay. Right. Again, we'll come back to the details of what HTML is and what are all these pointy bracket stuff, right, in a minute. I just want you to really, really high level what's happening, right? So what we're going to do, right, for the next 7 weeks is we're going to replace this app. Right? And we're going to replace it with our own content because we want to build stuff that we want to build, not this dummy stuff, right? So we're going to just throw this away. We'll throw that away, right? And we're going to replace it with our own welcome to web dev. And we're going to replace it, throw that away, and there it is. Welcome to web dev. Right? We just threw away all the boilerplate stuff, and we're going to replace it with our own. Everybody good? Okay, so I replaced it with a heading. One. So this is plain text. This is plain text. But if I surround it with some formatting tags, then it becomes a heading, right? A big, small. I can make it smaller or bigger, right? And so we're going to learn all about this. Everybody good? Okay, so we went over the various content of the root, right? We looked at each one of the app.tsx, right? And the output that is being rendered, right? And we saw that each one of these pieces of content, what they render on the screen, okay? And the welcome, and then we tried it out, all right? Now, one of the great things about what this allows you to do is that it allows you to create and break out the content into multiple pieces. Let's see the question in the chat. Is using Create React App a hard requirement? I'm sure we won't run into. Yeah, no, you could absolutely use other tools. Absolutely. Okay. We have the beginnings of a React application, right? Let's talk about deploying it and making it available. Right. So we want to be able to make the content of our React application available, right, to the rest of the world. Right now, right, our application is running on our local machine, right, and no one else can see it. Right? So here's our little simple application, not doing much, right? And so, but we want to make this available to the rest of the world. So how do we do that? Right? So what we need to do is to make all this content first, push it to a Git repository, right? And once it's in a Git repository, we can then use tools such as Netlify, right, to deploy the content from our Git repository. So if you don't have a Git client, you need to install one. So from Windows, you can download a Git client from this over here, or Source Tree app is also a nice tool. Right? Now, if you're running on Mac OS, you already have a Git client. Right? You don't have to install anything, or maybe you do need to initialize it and configure it using Xcode, right? The developer tools for Xcode. So yeah, make sure that the git ignore contains node_modules, that you're not inadvertently pushing content, right, that shouldn't be live in a repository. So certainly we did check that, right, that it is indeed node modules is there. And let's head over to GitHub and create a place where we can push our code, right? So let's do that. So over here, I'm going to take the name of the folder, right, and I'm going to head over to GitHub and create a repository for our project. I'm going to say new repository name is available, and I'm going to make it public. It's fine if it's public. And so now that we have that, we can follow the instructions here to push our content there, right? So we're going to go here, and from the command line, we can take a look at what files have changed so far. So we have just app.tsx. We make that small change. So let me put it back the way it was. I'm just going to put back the default. Let me make sure that it's running it. Yeah. So this is what we're going to deploy to the remote server. Okay. And so we have that. We're going to initialize this. We already have our repository initialized, so I don't have to do a git init. We're going to add the content locally on our repository. So let's do that. We can say git add everything. Right? We're going to commit it. Git commit. So it's first commit. Right? And then we're going to add this repository that we created on GitHub. Right? We're going to add it as our origin. So we say git remote add origin, that URL, and then we should be able to push. We're going to be able to push everything. push, oops, enter. So that's going to push our source code in our main branch. And here, if we refresh, we're going to be able to see our content. There it is. So this is all our content that we've generated so far, except notice that you don't have node underscore modules. Right? You should never see node underscore modules here in this repository. If for some reason you inadvertently push that, just remove that repository, trash it, start all over. Okay. Okay, so we have that. We push that to our particular repository, and we check to see that our content is there. Perfect. So once we have that in our repository, we're going to deploy it to Netlify. So Netlify is a service, right, that allows you to host your applications in a remote server, right? So that instead of it just running locally on your machine, it's going to run on a remote machine, right? So that is publicly available everywhere, right? So that others, your colleagues, right, future employers, myself, the TAs, right, they're going to be able to see, right, grade you, right, and praise you. What a great job you're doing, right? So create an account on Netlify, and once you're in Netlify, you can create a new site. So we can say add a new site. So we're going to import it from an existing project, which we do in GitHub. We just pushed it there. And you can tell, well, from where? Where do you want me to get the project? So we're going to get it from GitHub. I'm going to say, go to my GitHub. It'll probably ask you to authenticate, right? And, and log in, give your credentials so that it can log into your GitHub repository. And then you can search for, what we just created, fall 24. I think we have one single, I think I might have just one repository. Yeah, this one. There we go. So it says 2 minutes ago. That's it. I'm going to click on that. And team site name, I'm going to use the same as my folder name, as the name of my site. I don't know if it's too long. Okay, I'm going to check availability. It's available, so it's going to be that name, Canvas, yada, 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 Netlify app. Branches main base repository. It's going to build function, directory, yada, 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 environment. Okay, let's go and deploy. So, okay, so this is going to clone down my repository. It's going to run npm build, right, which is going to convert all my TypeScript, right, all my JavaScript, right, all that is converted into something that can be deployed to Netlify. Right, we can see the steps that it's going through. Notice that it cloned the repository, right, and it's going to go through npm build, building, starting the build, initializing, building, deploying, complete, deploy the folder, blah, blah, blah. Okay, it looks like it's done. And so we can open up the website, presumably, and notice that indeed, it's the same exact thing that we are running locally. So this one is running on my local machine. This is running on my remote machine, right? This one, nobody can see. Only I can see on my local machine. This I can share, right? I can copy this URL and send it to anyone, right? And anyone can see it. So I'm going to create a link here where you can see. I'm going to edit it. I'm going to put the URL here, updates, and so you can see right here the progress of the work that we've been doing. Also, my Git repository. I'm going to copy this URL and I'm going to put it as a link here in the resources so you can keep track of the latest work that we've done here in class, right? All the source code. And again, any source code that I push into that repository, feel free to copy, paste, right, and reuse it as if it were your own, right? And And you can use it as a start code, right? And then work from there, all the labs and exercises and assignments that we're going to be working on together. Very good. Okay. Right. So we've deployed it. Right now it's deployed. Now we're going to be using different branches throughout the semester. Yeah, let's talk about branches. So there's going to be several assignments that you're going to be working throughout the semester, and you need to be able to work on different assignments, even though the TAs might be still grading the previous assignment. Right? So we want to be able to break out, right, the work that you're doing into multiple branches, so that you can work on the next branch for the next assignment without, right, modifying the previous branch, because that is being graded by the previous by the TA. So when you complete assignment 1, right, and you deploy it, right, you can keep on working on assignment 2, right, but in a different branch A2, so that TA can look at branch A1, grade you, give you a grade on that, but you can keep working on the next one without waiting, right? So to do that in Netlify, you can you can go to site configuration, and you can go to the branches here in the build deploy, build settings, functions, dependency, branches. Here in branches and deploy context, you can say configure. Right now it's configured to only deploy to the main branch, right? And but instead we want to, if on GitHub you create different branches, like we're going to create branch A1, branch A2, branch A3, one for each assignment, right? We want all of them to deploy, not only the main branch. So I'm going to say all. And deploy preview, and I'm going to request against, yeah, let's say save. Save, deploy all branches. Okay, so that means that now if I create a different branch, so say I'm here, right? I want to start working on, say, assignment 1. I can say, git checkout -b A1, because I'm going to start working on assignment 1. And say I make a small change, right, to my app here, and say instead of this, I'll say, welcome to web app. Save. Let me make sure that locally it's what I want. So locally is saying welcome to web app, whereas the remote is saying edit source. So in main, it's still saying edit source, obviously, right? But now I'm gonna deploy to branch A1, right? So I'm going to go here. I'm going to commit this, and say getting started on A1. So commit. I'm going to push. So now that this is being pushed to my GitHub, if you go to my GitHub, you'll notice that there it is. My GitHub says, oh, somebody just pushed something to A1. It's listed there. Oops, let me refresh. See that A1 is there. I can click on it. I can see the change. If I go to my source, my app TSX, I see that I made the change. There it is. Welcome to web app. And notice that if I go to Netlify, I go to my deploys, notice that it detected that someone pushed to a different branch, A1, and it's building it. It's building it, right? It's now trying to deploy branch A1. And what it'll do is that it'll create a different URL for each branch, right? So that each assignment can exist in their own little server, right? In their own little version without colliding with one another. So I can click on this and notice that now, there it is. See that remote on branch A1. Notice that what happens here is that it prepends the URL of the application, it prepends it with the name of the branch dash dash. See that? Right. So you can have multiple versions of this, right? You can have branch A2 and A2 dash dash Canvas React Web App, and then A3 dash dash Canvas React Web App, each one in its own branch, right? So that they can coexist independently, so that TAs can grade you on the previous assignment while you're working on the next assignment. Make sense? All right. Everybody good? All right. All right, so let's talk about the first assignment. Okay. So the first assignment is going to give us a chance to practice the skills of HTML, of using HTML to build a user interface. Right? Again, so the course is split up into two halves. Right, the first half talks about building a client, and the second half talks about building a server. Right, the web applications in general are built using this architecture of client-server app architecture. And the client usually is responsible for providing a user interface, right, to the user, so that the user can interact with the application. And part of building that application, that user interface, is to use HTML to render the content in the screen on a browser, right? So yeah, so the browser is our client, right? And it's running software in the browser, right, using React.js, right, that renders DOM, renders HTML, CSS, right, to paint something on the screen for the user. So all my assignments build on each other. This is the first of them all, right? And they all two parts, right? They have the lab part, right, that gives you a chance for practicing various skills about the particular topic. So in this case, the labs provides a whole bunch of exercises for learning about HTML. And then the second half, so all my assignments are like this, right? The first half is learning about a topic, and the second half is about using those skills to build application. So we're going to be building Canvas, right? So Canvas, so we're going to be building this. We're going to be building this right here. So we're going to be learning how to navigate, to a dashboard, right, and then click on a particular course, right, and then once you're going to that course, you have this sidebar that allows you to navigate to modules and assignments and people, right? So we're going to be building all this, right, learning how to display it, then how to start typing, and this actually searching for things. So it's filters, right? And filtering by roles, but how to create assignments, remove assignments, edit assignments, create modules, remove modules, edit modules, right? And so we're going to be doing this throughout the semester. So the second half of all the assignments is on the previous work that you've done, building Canvas. Okay, the first assignment uses just plain old HTML. So our first screens are not going to look very pretty, right? Our instead of the dashboard looking this nice and pretty, is going to look much uglier, right? And instead of having these nice sidebars like this, the first version in this assignment will be these ugly hyperlinks, right? Which is it's more or less the correct layout, right? But certainly it's not as pretty as the real thing, because it's not the focus of this assignment. The focus of this assignment is, how do I create hyperlinks? How do I create headings? How do I lay it out in a grid, right? In a row, in multiple columns, right? So that's HTML. learning how to create content. The second assignment is going to revisit everything you've done in the previous assignment and is going to apply CSS to make it pretty. Right? We'll make the background black and the highlight white. We'll make the font correct. Then we'll add some some icons. Right? We'll make it the right size. We'll make it so that it's responsive. Right? But what we mean by responsive is as you resize the screen, different content appears and disappears. Like for instance, this sidebar over here, when you make it small, notice that it disappears. This content on the right-hand side disappears because it doesn't fit, right? And as you keep making it smaller and smaller, then we hide the left-hand side, right? We collapse it. So that's all CSS, right? On how to make it responsive, right? So that it can be consumed in smaller screens. Okay, but that's the second assignment, and other assignments will build on the second, and then on the third and the fourth, and they all build on each other. But the first part is all about basic skills about that particular topic. So today we're going to get started on the labs for the first assignment. We're going to learn, we already learned how to create React.js, create the, we created the server, we created a little application, but we're going to be building on this as we go, right? We're going to go through learning about headings and paragraphs and lists and tables and images and creating forms, text areas, buttons and whatnot, right? Some of the very, very basic stuff today. Okay. All right. So let's go through this. Right, so let's talk about HTML. What is HTML? So HTML stands for Hypertext Markup Language. Again, I'm big on acronyms. In the first quiz, you're going to be asked, what does the HTML stand for? Right? So make sure you know that it's hyper, and then text, and then markup, and then language. Right? So yeah, it's a computer programming language, right? That is used for taking just plain text, right, and then surrounding that text with markup, right, with opening and closing XML tags that the browser is going to use to format the content using those tags. So plain text, right, you surround it to format it, right? And typically you would use just plain old HTML documents, right? Like we showed you earlier, right? In here, you have your index.html. Before there was JavaScript, right? Before there was jQuery and React and whatnot, you would build applications just with plain old HTML. So everything would look like this manually, right? You would have to edit it manually. When jQuery came out and Angular and now React.js came out, right? Folks, they still build static content like this, but today dynamic content is more like this, right? Where there's a combination of JavaScript executable, right, and combined with XML, right? So now XML is embedded inside of a computation function, some algorithm, right, that is responsible for computing the output of this, right? What this looks like. Right? So today's is much more rare that someone would write, just plain old HTML. Instead, they would write a function that calculates the output of HTML. Okay, and that's exactly what we're going to be doing, right? Nevertheless, it's useful to understand what this all HTML is all about, right? So we'll go through HTML. What is it? Well, first, if it's a static ASCII file format, right? That typically has the extension .html or .htm, and it contains XML, right? So again, XML is a generic language, extensible markup language, right? And then it has any number of vocabularies, right, that are used for different purposes, right? This is specific vocabulary is used in the world of browsers. Browsers understand this vocabulary of XML as a language for formatting user interfaces, right? So it all starts with this outer HTML. Right? So notice that it's a root, then inside you have head, and then you have body, and head contains meta information that is not rendered on the screen, whereas body contains the content that actually gets rendered on the screen. Right? In the head, you have things such as maybe the author, the title that gets rendered on the name of the window. You also have references to other resources like cascading style sheets, right, that say how things should be rendered, right? The colors, the background, and fonts, and whatnot, right? Plus, you might have references to JavaScript libraries, right, that can run and execute in the browser when this page gets loaded, right? And it might manipulate your content. Okay. You have also comments in HTML, and the actual content goes in the body. Right? So yeah, so HTML is the root, then the head is the meta information, and then the body might have the content. Right? And the content can have plain text. If it's plain text like this, the browser ignores any formatting that you add, such as new lines, like tabs. If you add any tabs or any extra spaces, or new lines, it ignores any of that. Because that formatting is for us humans. The browser, if you want explicitly to add vertical spacing or any horizontal spacing, you have to explicitly use tags that are formatted that way. Right? Otherwise, it just ignores any extra spaces. You would need to add paragraphs and whatnot. Now all these tags, what they do is that they are used by the browser to create what is called a DOM, D-O-M, the document object model. Right? So the DOM is a data structure. Right? It's a tree-like data structure, right, that we can create manually. Right? We can create manually by manually typing this XML document. Right? And the browser parses this XML document, and it creates a tree-like structure out of that static text. Or you can create a function that creates those nodes, that data structure. You can create a data structure programmatically. Okay? And we can see it here. You can take any browser, right? And you come here and you can see the DOM right here. You say inspect, right? And you can see here a tool called the Web Development Tools that has a whole bunch of tabs at the top, which we're going to see throughout the semester. But for now, let's look at the first tab, the Elements tab. So the Elements tab contains the DOM, right, the Document Object Model. This is the result of the user interpreting the HTML that it parsed from index.html. Actually, this is index.html, right? It parses that HTML document and it creates this tree-like structure, right? That as a root is the HTML root node, and then it has two subnodes. The header doesn't render anything, but it has a whole bunch of meta information there. And the body is what actually contains the content that is rendered on the screen. Right? And in there you see the ID, the root. It's this over here. Right? It's this over here, this root right here. That is that root right there. Right? And notice that the root doesn't contain anything. Why? Because the index is going to inject the content of app. And what does app come back with? This div of class name app. Ooh, there it is. Div class app. Right? We'll talk in a minute why class name is not class here. We'll talk about it in a second. Then you have this header. There it is. There's the header. And then you have an image. And there it is, the image. See that? Then you have the paragraph. There's the paragraph. Right? Actually, this might be useful if I put these side by side. How about that? We put this side by side over here. So I can see this like that. There we go. There we go. So we have the paragraph. We have the paragraph. See that? And we have the hyperlink. There it is. And we have the closing header. So the DOM is the data structure that the browser is actually rendering. It interprets this, it gets dynamically generated, and then it's what controls what you see on the screen. Make sense? Now, the DOM can be manipulated manually. I can come in here and I can edit this. I can say, welcome to app, a whole bunch of exclamation points. And notice that I modify that, and notice that it changed the user interface. So that, see that? Now, if I refresh, if I re-render it, it goes back to the original, right? Because changes that I make to the DOM here in the tool are not made permanent. If I wanted something permanent, I would need to edit the source code, right? If I save, then it's permanently modified. Yes. So I can change it manually, or I can create a function that can calculate and run and generate and calculate this data structure dynamically for me on the fly, or based on some user input as I click on the button, right, or drag or type in something, and I modify this data structure, and by that I am controlling what the user interface renders. Make sense? So yeah, so that's HTML. Okay. So yeah, so the DOM is a data structure, right, that has a whole bunch of nodes. Now the browser is nice enough to render it, right? Nice enough to render it, this data structure, kind of following the same pointy bracket syntax that we typed manually, right? And it uses the same syntax over here. That's to make it easier for us to see, oh, that node over here is that text that's over there, right? But internally, it doesn't really need to use pointy brackets, right? It's just a tree with nodes and branches, right? It's nice that it renders it for us human beings, right, to make sense out of what we wrote. Now, I did say that why is this class and this is class name? Now, the true syntax for HTML is that it's class, not class name. Now, the thing is that this over here is it's a abstraction layer, right? This is a language. This is kind of like a fake language, okay? It's kind of combines two languages into one, right? The language is JavaScript or maybe TypeScript and XML, right? An XML language. So the language, notice the extension is .tsx, right? TS for TypeScript and X for XML. Right? It's a language that looks to blur the barrier between two languages, right? It tries to blur the fact that half of this code is JavaScript or TypeScript, and half of it is XML. Right? Notice that you can go from JavaScript to XML, right? Back to JavaScript, back to XML. So you could go back and forth, right, between these two worlds, almost seamless, right? And that's the intent. But you have to take care of the fact that this is a This is an abstraction layer. This is not really understood by any browser. Browsers do not understand this language. Browsers only understand HTML or JavaScript, right? They don't understand this TSX, right? So this gets compiled, or some might say gets transpiled into its equivalent JavaScript, a JavaScript that the browser can understand. Right? So it gets compiled down to just plain old JavaScript. And so when in that conversion between this high-level language and the low-level JavaScript, right? JavaScript has some syntax, right, that collides with some of this naming convention. And one is that HTML, for instance, has a keyword called class, which specifies the look and feel, right, on the colors and fonts for that particular element. Okay, but in JavaScript, class is a reserved word. So because I'm mixing two languages and there's a word that means something in one language and means something else in the other language, I need to come up with a brand new language or a brand new name, right? So class name is so that, right, we can avoid using the reserved word class, which means two different things in the two different worlds. Make sense? But when it gets translated down to what the browser can understand, it's class. Make sense? There's several examples of that, right? Of discrepancies from the real language and the abstract language, and I'll point them out as we identify them. Okay. All right. Okay. Let's get started on the first lab. So we're going to create a lot of components, a lot of content throughout the semester. Right? And one of the great things about using JavaScript or TypeScript or some programmatic language, as opposed to just static HTML, is that you can use the abstraction mechanisms of programming languages, right? And so one of the things that our programming languages can do is that you can create abstractions, right? And programming language has many different mechanisms for abstraction. One of the common ones is to have functions. Functions is an abstraction mechanism, right? It allows you to encapsulate some algorithm, give it a name, right? The name is the abstraction. Give it a name and then invoke it and run that algorithm, right? Bring it in, import it, right? And then run it, and then abstract it with just by its name. So let's show you what I mean by that. Right? So for instance, I might have here. Let me replace this with div, where we have a header that says, welcome to web dev. And so there it is, welcome to web dev. Okay, and so I can and then here down here I might have labs. I have here the labs, right? And on the labs I might have lab 1, lab 2, so on and so forth, right? Now, as you can imagine, this content could get pretty big pretty fast, right? Because each lab, right, has dozens of exercises. So this one component, this one function would become very big very fast, right? Ideally, I want to be able to break this out into multiple smaller components that I can then bring in and combine together. right? That's a very common way of abstracting, creating abstractions, and then combine those abstractions to make more complex things. That's very, very common. So instead of having all this content, huge amounts of content, I can break it out and create a component, right? That is called labs. .tsx. And in here, I would like to be able to do is bring this content over there. Again, so I can remove it from here, right? And bring it over there. So I can say, export default function labs, and then return the content that I just cut out over there. And then close that up. Okay, so I moved it here. And then from where it came from, I can then import the labs, import labs, and then you call in that function, gets executed, and then this whole thing gets re-rendered, replaced with the content that is calculated by the component that I just created. See that? Right? Notice that these components, that this tag, that's not a valid HTML tag. I just made up that tag, right? The name of that tag is based on the name of the file. I called it labs, right? And so that is the name of the component, the new component, right? These are native HTML tags, which we'll learn in a minute, right? But I can create my own tags, my own XML tags, my own vocabulary, right? And so this is one of the main aspects of React.js, that it encourages you, right, to break out bigger component into smaller constituent component, right? So that you can deal with very complex user interfaces, breaking it up into smaller pieces that maybe you can break it out and say, okay, well, you work on this and you work on that, right? And then we'll all combine it into one single user interface, right? So same thing with each one of the labs, right? So say I would have maybe a lab 1, lab 2, and so forth, right? So for instance, I might say, create a lab 1.tsx, right? So I might say, export default function lab 1, return, right? And then in here, put all my efforts of lab 1, and the dozens of exercises for lab 1 would go in here. So let's put it in here, like that, right? And in here, I can then bring in lab 1. Oops, like that, right? So it's there, right? So I can do the same thing for all the other ones, right? So lab 2, okay, and then export default function lab 2, h2 lab 2, that, and then here bring in lab 2. Everybody good? Okay. All right. Oh, I need to import it. Import. There we go. Okay. Now there is a flaw, that these are all the top directory. So if I keep doing this, right, I'm going to just keep creating many, many more files. Ideally, I could put this maybe in a separate folder, so I can also deal with the complexity and the number of files. Right? So creating components allows me to deal with the complexity of the screen, breaking it up into smaller components. That's great. But now I have proliferations of files, right? So that too, I need to be able to deal with the complexity of dealing with a whole bunch of files. And typically what we do with that is maybe we create different folders, right? Where we can break out the different works, right, in separate folders, right, to deal with the complexity of many files. So instead of this being a file with a whole bunch of lab 1, lab 2, lab file, maybe this should have been a folder of labs, and in there I would drop in those lab 1, lab 2 in there, right? So let's fix that. So instead of having lab.tsx, ideally it would have been a folder called labs, okay? And then all these would live in there, okay? Now it's going to I move that in there, and notice that it broke my application. If I go back to app.tsx, it says, oh, I can't find labs anymore because I moved it. Okay, but notice what happens if I replace labs with index.tsx, it works again, right? So let me show you what that means. What does that mean, right? So index, the keyword index, or a file whose name is index, right? Just like this index.html here, this index.tsx, right? And now this index.tsx here has a special meaning, right? It means that this is the kind of like the entry point or the landing, right? Or the default thing that gets displayed, right? Within a folder. Here, HTML is the default file in the public directory that you would see when you navigate to the root directory. Same thing here. This is index.tsx is the entry point of the source folder. Everything starts here, right? It loads the root, it injects the whole content into the root, blah, 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 right? And in here, the entry point of labs is index.tsx, which does everything else, right? And so when I import it, app.tsx, right? Let me, there we go. What this is doing, this is saying labs, oh, and you're not telling me index.tsx. Well, that's implied. It's implied, right, that you mean the folder labs and the index.tsx that is in there, right? You don't have to explicitly tell me. Actually, if you try to explicitly tell me, it would complain. Right? So you just leave it with labs, but it's a folder labs, but it has the index.tsx. Make sense? Right? This is something that we're going to do a lot of times because we have plenty of chances to practice it, where we have a folder and then you have an index.tsx which references everything else. Okay. All right. So same thing with lab 1, lab 2. We're actually going to have we're actually inside of lab 1. We're going to have a lot of labs under lab 1, right? So we're going to have to do the same thing over here again. We're going to have a folder where we put lab 1, another folder for lab 2, and so on and so forth, right? So we'll have to do this again, right? But we'll leave it like that for now, right? Okay, so we understood you're creating different folders, right? Now let's do it for lab 1 because we have to get started on lab 1. Let's create a directory. Let's create a directory here, and now the directory doesn't necessarily have to have the name, right? Although let me see in the assignment, how do I call it? Yeah, I call it lab 1. Yeah, I'm following the same name as the. So instead of being called file lab 1, because it's going to have a lot of exercises in there, we're going to have a whole folder called lab 1, right? And then we're going to move this in there. I was going to complain because we just moved it. It says, do you want me to rename the files in my folder, in my files, that imported? I'm going to say no, right? Because it doesn't know that I'm going to rename the file to index.tsx. So I'm just going to say, no, don't do anything. Say no. It's broken, but it'll be fixed because I'm going to rename it to be index. Okay, now it works just the same, right? So in here, this is just not parsing again. There we go. That. All right. Okay, so within lab 1, now we're going to work on a whole bunch of exercises in here. Okay. Right, so let's work on headings and paragraphs. Right, so these are some of the simpler elements or HTML tags, right, that we're going to be learning about today. Right? And basically, right, they allow us to change the font or the size of the content, right, to serve as something that we want to highlight, right, or we're presenting a major piece of content, right? And there's different sizes, H1, H2, all the way to H6, and they're for different heading sizes, right? And the bigger the number, the smaller the heading is. Right? So in lab one, right, let's create an example of a heading. So we're actually been using headings for the examples already. Let me just copy the whole thing. Just copy the whole thing. If I go to lab one, and yeah, go to lab one, I'm just going to replace this whole thing. So there it is. So we have a lab one HTML examples, right? And we're going to talk about headings, right? The different sizes. Notice that the bigger the number, the smaller the heading, right? That's it. That's very, very simple. Very, very simple concept, right? Now, paragraphs is so that you can create vertical spacing, right, between the content. As I mentioned earlier, any extra spaces, tabs, or new lines is just ignored by the browser, right? So for instance, if you want to add any vertical spacing, then you have to explicitly use tags such as p or paragraph, right, to add that. So let's, for instance, if I go in here, right, and I add that here at the bottom, these are headings. This, I guess, would be H4 paragraphs, and it would be down here, paragraphs. So paste that in there, so there's two paragraphs. And notice that the vertical spacing is there because I added the paragraph. Notice if I remove this, notice that it removes any spacing, even if I added the extra space. Now, if I save it, my IDE, because it knows that the browser is going to ignore it, it actually removes the extra spacing, right? Because it says, you didn't add any extra tags, it's going to ignore it. So I'm just going to munch everything together. But if I put back the tags, it does add the vertical spacing. Okay. All right. Yeah. So any extra spacing that you add is just going to be ignored. You have to explicitly add the tags. Okay. All right, so let's look at some other really simple tabs, such as lists. Right, so lists is when if you want to be able to list content in no particular order, or if you want ordered. So you have two types of lists: ordered list and unordered list. So unordered lists, they use the moniker the tag UL for unordered, and OL for ordered lists. Right. So this is the first set of tags that are actually a combination of tags. You have an outer tag UL and closing tag UL, and then you have an inner tag LI, right, that this is for you configuring every single line item. Right? So the outer ones kind of like encapsulates the list and also sets the overall look and feel, whether it's bullets or numbers or Roman numerals or whatnot. And then inside you have the line items, right, for each one of the bullets and whatnot. Okay. So here's an example where we're displaying maybe a list of how to make pancakes, right? So if we add that here, and then this is for headings. So here we'll have the lists. So here's the list. Notice that even though I had added the new lines, it kind of ignored it. It munched up all the lists into just one single line. So if I want to add make sure that this formats as a list, I do need to add the extra format, right, of adding the OLs and the line items, and then it'll render as an ordered list in a specific order, right? So let me replace that. How to make pancakes? Yeah, so I'll just replace this. It's like that. So now it pays attention to my format and it renders it with numbers, right? So notice that the here I'm not explicitly adding the numbers. It is being formatted with the numbers. Okay. And then you have an unordered version, right, which uses UL. Okay. And then you have tables, right, that allow you to render things in a tabular format, and that uses another combination of tags, right? One is the outer table tag, right, and then you have a head for the tag where you have the headers. Then you have the body, the main content, where you have the main rows of the tables, and then you have a footer. Right? So here's an example, right, where we can render like a whole bunch of quizzes that we might take over the course of the semester. Right? So maybe you have tables. And so here's a table that has a single row of just one quiz, and it's rendered as follows. Notice you have the outer table where you can configure the border style here, which is border 1. And then width 100 expands it so that it takes up the entire width of the screen, right? And let me remove some of these comments here. Then you have the head here, which allows you to list a row of headings like quiz, topic, date, and it formats it to be a little more darker, centered, right? And then you have body, where you have multiple rows of the actual content, right? And what we're going to be using it for is for rendering things such as the people's table. This people's table, that is going to display a list or a table of users, right? Why is this not rendering my table? What's going on? Did I lose communication? Oh, there we go. So a list of all the users. Another example is the grades, right? So grades is also an example of a table with lots and lots of columns, lots of rows. And in particular, it's responsive that you can scroll left and right without scrolling the entire screen. You can also scroll up and down, right? Without scrolling the entire page, right? So that's nice. So yeah, and we can obviously add more rows, right, for a whole bunch of quizzes, right? And it'd be maybe quiz 2, and then 3, and then 4, and whatnot, right? Okay. So now we can commit this to a repository and say I'm going to add everything. A1 lab, right? So I'm going to commit. I'm going to push, and so that should kick off a build on my Netlify. Let's go to Netlify. Go to deploys, and notice that it kicked off. It's starting up, right? Certainly, it got pushed to my Git repository. Notice that if I refresh, we'll see that now I have labs, my lab 1, right? All the work that we've done today is here, available for you, right? If you want, you can copy this and paste it and use it as your own. And meanwhile, this is being built, and it's being cloned, it's being pulled down, it's being compiled, and it failed. And it failed probably no config file, our dependencies. Okay, it's saying that I'm probably not, logo is defined but never used. Right, okay. It's very strict, right, about checking to see if you have anything misleading. So we can fix that. So here we can remove this logo is not being used. So let me do that, fix that. Again, added remove logo, commit, push, and we should be able to see if that fixed it. Deploy. Okay, starting up again. I removed the logo. There it is. So we can do that. Some of these are really trivial. Why it fails, that it really shouldn't fail, right? So we can configure this. So we go to site configuration, and in the build, where it says solve build continuous repository build settings. Okay, we can configure, and we can say that continuous integration false. Continuous integration false. I think that is, CI. Yeah. So we can turn off the strict checking of some of these silly errors. Let's see the deploy. Okay, move. Did it work? Okay, it worked. And so we can open it up. And there it is, right? All the work that we've done today, right? Of the lab one, the HTML examples, the list, the tables, right? And so you can take this and keep working on it, right? And complete the lab one. Please make an effort to complete the first lab one for the assignment for this week. And then when we come back next week, right, we can work on the second half of the assignment. We're gonna get started on the using all these skills of HTML, right, and to actually start building Canvas. Okay. So the submission for each assignment, right, will be that you'll be sharing a link to your repository. And so this link over here, that right, this link right here. So you'll be submitting this link, and you'll be submitting, right, this URL right there. So for assignment one, it'll be this URL, A1 dash dash Canvas React app, blah, 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 right? For assignment two, you will submit A2 dash dash Canvas React web app, blah, 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 blah. Right? For A3, it will be A3 dash dash, yada, 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 yada. Okay?